Welcome back to the One Chart at a Time video series. Today we're going to learn about the Raincloud plot. The Raincloud plot is another chart type that we can use to show distributions in our data, and it really combines multiple graph types together into one. And to help us learn more about this particular chart type, we have Len Kiefer, who's the chief economist at Freddie Mac, to help us understand more about the Raincloud plot.
My name is Len Kiefer. I'm an economist working at Freddie Mac, and I help people understand what's going on in the economy and housing and in mortgage markets. Data visualization is a powerful tool that I often use to help me communicate analysis of trends affecting the economy. While in many cases, a standard line or a bar chart is going to do the tricks, sometimes, maybe during exploratory data analysis or in communicating, something a little more elaborate is useful. One visualization that I like to use is a combination of a density curve and a jittered dot plot. When I use it to visualize mortgage rates, I call it a rate cloud. This chart here is an example of the rate cloud. It shows a distribution of US weekly average mortgage rates from 2010 up through 2020. Each week, my team at Freddie Mac runs a survey of lenders across the country on the rates and terms for the most popular mortgage products in the country. By far, the most popular product is the 30-year fixed rate mortgage. Every week, we collect the average interest rate that a consumer might see if they were out in the market looking to get a home loan. This chart here shows the distribution of those rates week by week and year by year from 2010 through the middle of November 2020. Each individual week is represented by a dot. On the y-axis, we have year, and on the x-axis is the US weekly average rate, 2.84% for the week of November 12th, where I've shown with a dotted white vertical line. Within each year, the points are jittered vertically. So it doesn't really, the vertical distance within a year doesn't really mean anything. What matters is the position on the x-axis. But the vertical jittering allows it to prevent overplotting and gives you a sense of sort of a rain cloud effect. The cloud above the points is a density curve fit through those observations. So that gives you a sense of the distribution of where rates are. So the higher the peak means the more concentrated rates are. For example, in 2017, you see a lot of these values clustered right around 27 or 4%. The peak is very high. In other years where things are more spread out, you see a flatter curve or sometimes multiple peaks where there were sort of bimodal distribution. You can see in 2020 that the interest rates have fallen to record lows, where the distribution lies far below anything we had seen in prior years, and most of the year is far out in the tails compared to prior years. That gives you a sense of how the distribution is. There's no new information. You could get this out of a line chart, but in my estimation, this helps, I think, to bring out some of the features of the data that you might not see if you were just looking at, say, a standard line chart. And I found that when I share those with people, it gets a lot of engagement. People find some visual interest in this kind of chart. I happen to have made this chart using the R programming language and software, the GG Ridges package by Klaus Wilke, which is open source and available. I've shared code for this and related charts on my personal blog, lenkiefer.com. And I often share these via Twitter or LinkedIn. You can connect with me there and see them in real-time updates. This and all these different variations of this chart, I think, is a powerful way to understand what's going on with the data in something a little bit different than the standard chart, create some visual interest, and maybe helps you see things in a slightly different way than you might with a more standard chart.
And thanks to Len for that great review of the Raincloud plot. Now, I should note that I've included one of Len's graphs in my book, Better Data Visualizations. I think it's a great example of how you combine summary measures of distributions and individual data points. So come back tomorrow. We're going to continue learning more about data visualizations that are used to show distributions in your data.